These are the double angle formulas that you need to be able to reference when you have sine of 2u, tangent of 2u, and cosine of 2u. So make sure that you can reference these. How do I solve 2 cosine of x plus sine of 2x equals 0? For the first time, we've encountered a situation that I have a double angle, sine of 2x, double, 2x. And up until this point, I don't know what to do with that. But now I have this formula on the previous page that, I'll write it down at the bottom, sine of 2u equals 2 sine u cosine u. So that allows me to rewrite this. This I don't change, 2 cosine x, plus, now in for sine of 2x, I substitute 2 sine x cosine x equals 0. Now why is this important? Well, that's important because now I have a common factor. My common factor, my GCF, is made up of a 2 cosine x. And when I factor a 2 cosine x out of the first term, 2 cosine x divided by 2 cosine x is 1. And when I factor a 2 cosine x out of the second term, I'm left with sine of x. And both of those factors equal 0. Why is this important? Well, to solve, I can set factors equal to 0. So I set 2 cosine x equal to 0. I set 1 plus sine x equal to 0. And I solve those problems individually. From here down, it should be review. Subtract 1, subtract 1. Where in the world is sine x equal to negative 1? Cosine, sine. So which ordered pair? Where's the ordered pair that has the y output negative 1? And that's at 270 degrees. It's down here. So that would be 3 pi over 2. And then divide by 2 and divide by 2. Cosine x equals 0. Ordered pair, I'm looking for, where's the ordered pair that has 0 comma something? Well, there's 2 answers for that. One of them is up at 90 degrees, and one of them is down at 270 degrees. But in terms of pi, in terms of radians, excuse me, that would be pi over 2 or 3 pi over 2. Okay, so if I add plus 2 pi in, I would get all values of the answer if I give more revolutions around the unit circle. In example 2, we want to analyze the graph of y equals 4 cosine squared x minus 2. And this is important because, once again, we can practice pulling out a GCF. And my GCF is 2. If I factor out a 2, I'm left with 2 cosine squared x minus 1. Y equals 2. And in for this, I'm able to substitute cosine of 2x. So, in summary, I have 2 cosine of 2x. Now, with this, because I've rewritten this equation, I should be able to find key points. What's my period? My period is 2 pi over b. What's my b? My b is 2. That's where I got my b value from. So that means that my new period is 2 pi over 2, which is pi. So my first point occurs at 0. My last point occurs at pi. What's my amplitude? My amplitude is 2. Now, do you remember the normal key points for cosine? What's the cosine of 0? Cosine of 0 is, so the goal is to use the following information to find sine of 2 theta, cosine 2 theta, tangent of 2 theta. And the information is that cosine of theta is 5/13 and theta is between 3 pi over 2 and 2 pi. And so that means that theta has to be in quadrant 4. All right, so this information here tells me that I'm in quadrant 4. So in quadrant 4, I draw my theta, and the adjacent side is 5, and the hypotenuse is 13, and this is the common right triangle that this other side has to be 12. So, and because I'm in quadrant 4, the y value is negative, and so this adjacent side has to be negative 12. So, to find the sine of 2 theta, the formula is 2 sine theta cosine theta. Sine theta from my triangle is negative 12/13, and cosine of theta is the fraction 5/13. So if I multiply all of my numerators together, I get negative 120, and if I multiply 13 and 13 together, I get 169. Now, I'm supposed to find cosine of 2 theta and tangent of 2 theta. So what's the equation for cosine of 2 theta? Cosine of 2 theta is, there are several of them, but I'm going to choose to use 2 cosine squared theta minus 1. So when I sub in my numbers, I get 2 cosine of theta is 5/13, but I have to square it, and then I subtract 1. 5/13 squared is 25 over 169. I multiply by 2, and I get 50 over 169 for this fraction, keeping in mind I need to subtract 1. When I subtract 1 from 50 over 169, I get negative 119 over 169. So the cosine of 2 theta is negative 119 over 169. And my answer for sine of 2 theta was 120 over 169. Tangent of 2 theta would be equal to sine of 2 theta over cosine of 2 theta, because once again, one of our basic identities is tangent of theta equals sine theta over cosine theta. It's one of our basic trig identities. So I can throw a 2 in front of all the thetas and still use these for the double angles. So, because I already know sine of theta and cosine of, sine of 2 theta and cosine of 2 theta from my earlier work, I can sub in that sine of 2 theta is negative 120 over 169. And for cosine of 2 theta, I can plug in negative 119 over 169. I can multiply by the reciprocal to simplify this complex fraction. And the nice thing is, in the denominator of the complex fraction, everything cancels out. And the 169s cancel out. Negative times negative is a positive. And I'm left with 120 over 119. Here are the power reducing formulas and the half angle formulas that you will need to be able to reference at different points when we need to use these formulas to rewrite a problem. Here are the product to sum formulas and the sum to product formulas. Once again, we may need these at times to rewrite a problem.